In this video, we will continue with the iterative process, but we will look at the process in other areas of mathematics. Okay, now you can go through this. This is just very interesting because you hear it a lot. So the golden ratio. So let us start by explaining the golden ratio and show that how you can use the iterative formula to determine this irrational number. So you can just go through that. It's in the textbook on page 563. So you will find it in the Namibian AS-Level Mathematics textbook, y equals mx plus c. Then you can continue and you can look, this is on the next page, how I use the iterative process and actually generating that answer. Okay, and then you can look at the connection between the golden ratio and the Fibonacci sequence, and then at the end, at the golden ratio, the Fibonacci sequence and the golden spiral. Just for the interesting, but you can even go on the internet and you can also read a little bit more. It's just things that's very interesting, and you see it in nature. Okay, but what I want to do is I want to focus in this video on other areas. How do we use that? And this first one is bringing actually chapter 4, where we did this. Okay, so the diagram shows a chord joining 2 points A and B on the circumference of a circle with center O and radius R. The angle AOB is alpha radians, where this angle is between 0 and pi. The area of the shaded segment, and this is very important, the area of the shaded segment is 1/6 of the area of the circle. Meaning, we're going to compare it in two ways, but this shaded is 1/6, or make it a little bit longer, then meaning the rest of the part is then 5/6. Just keep it in terms of the area of the circle. Now, they say, show that this angle satisfies the equation. Okay. So let's start. You can revise chapter 4 and you can look at circular measures just to find especially the area of the shaded segment. But I also showed you here on your formula sheet, you will also find the area of a sector of a circle. And there, do you see that is exactly the formula that I wrote there. Okay, but this is coming from ordinary level. So what is the area of the triangle? Let's first find the area of this triangle in terms of R and in terms of the angle. So can you remember, it's half, and then it's this side times this side, multiply sin of the included angle. Okay, so this is coming from ordinary level. Okay, now what is the area of the shaded segment? So if I want, I must first take the area of the whole. Okay, let's just say that's going to be the area of the sector. It's going to be red. But let's just take the area of the whole. Okay. And then we subtract the triangle. Okay. So it's actually the area of the whole sector. And so I have to make this one not red. I will rather make this one then just yellow. And I subtract the blue. Do you see? And then I will end up with the area. And remember, that was also 1/6 of the full circle. Okay, so I take the area of the sector. Instead of the angle, you just write that alpha now, minus the blue. Okay, so there's my expression. Just keep in mind also, what is the area of a circle? Pi r squared. Okay, so the area of a circle, okay, I didn't put it equal. I just compare it because it's not equal. It's 1/6. Are you with me? So I'm comparing this in terms of two different things. First, I'm just comparing it in terms of the total area. Okay. So in terms of the total area, it's, I just want to move a little bit lower. It's 1/6 of the total area of a circle, and that's pi r squared. So there, in terms of the area of a circle. But then I compare it also in terms of my segment. So I'm taking this whole whole area of the sector, okay, and I subtract the triangle, and then I find that segment. Okay, so there are area of the shaded segment, so it's just then putting this one, and in terms of, it's now basically equal. And now I'm just going to simplify it. So if I simplify, I'm taking out, so can you see, there's a half r squared half, so I take it out and I'm left with this. And then I'm basically just divide both sides by a half r squared. So it's like I'm dividing there, my color is not strong enough, by a half r squared. Divide a half r squared. So basically, I'm ending up there with 1 over 6 pi r squared divide a half r squared. So luckily, the halves cancel out. And now I can basically just say it's 1 over 6 multiply the reciprocal 2 over 1. You can even use your calculator. It doesn't matter. It goes in 1, it goes in 3. And that's where I got that third and the pi was left. I just showed you it. There I showed that. Okay, and then I just want to now get a little bit of clear there. And then I continue, and now I'm just basically, say I leave this angle on this side, and I basically just swap the sides at the end, and I take that over, it becomes positive, and I swap the sides, and that is what they wanted. Can I just show? I actually had to say therefore, because I'm just changing the angle to x now. X, or I actually change it in the next question, but they show that. So therefore, x is equal to third pi, just write it correctly, sorry. It was just this equal that was bothering me. So to a third pi plus sin x. I'm just taking the angle to x now. Okay, and it's just helping you for the next one. So verify by calculations that this angle is between this. I think in a new print, I will rather go, and I will just check the original question, but I think I will rather go and just put there alpha, there alpha, and there alpha also, because now I'm connecting with this, but it's not an influence, it's still the same. Okay, so now I say verify that this angle is between this and this. Just do it like in the beginning of the chapter. I substitute this into that equation, but don't forget, please don't forget your previous work. If this, I'm taking it now in terms of x, okay, but I could have taken it also, I just put it there in terms of x, but if I was putting it in terms of alpha, it would have also worked. I could have just say 1 over 3 pi plus sin alpha minus, please remember what we always did. We bring this one over. Okay, are you with me? And now if it's in terms of x, it's just going to be 1 over 3 pi plus sin, okay, let's just get that pen correct. Sin x minus that x. Okay, so can you recall? We always took this over. So now I substitute this in. And just press it, make sure your calculator is on radians. So press 1 divide 3 multiply, I say shift pi equals, and then I say plus sin, and then I say a bracket, and I say 1 divide 2 multiply shift pi, close the bracket, minus bracket, and then 1 divide 2 multiply. I shift pi. I say shift pi because my calculator works like that. That I must go press shift. And then I get three significant figures 0.476. And then I do the same with this one. The same with the second one. And I get and the change of sign indicate the presence of a root. Okay. And then I go on. Now I use the iterative formula. They gave it to me, with initial value 2. And remember, now I don't take that is just my beginning. This is fx, capital letter fx. Okay, it's almost like this was small letter, are you with me? And this is capital. Just take note of the difference. Okay, So now I'm basically just going to substitute it in. Okay, in that, so press 2 equals, and then go and say 1 divided 3 multiplied pi plus sin answer, and then equals, and you get your first. And remember to give it to 4 decimal places and approximate to 2. Equal, and then to 2. Equal 4, and then to 2. And then check if this. You can, because I will show you now, sometimes it changes again, you can press equal. I want to show you this because I see it in the question papers also. They will say, show significant irritation to justify an accuracy of 2 decimal places until you come to that 1,97, or show that there's a sign change in the interval. So I just show you the OR process, and I want to do it in the final question also. So I'm just going to show you, I need this answer, but what I do now, I take a little bit before. So I subtract, I take 1.9, and then I make, it's almost like limits of accuracy. I take 1.965, a little bit before, and a little bit behind, 1.975. It's almost like I prove that the angle is there. And I do exactly the same what I did here. I substitute, but I substitute now that angle in. Are you with me? And I get this answer, positive. Just take note, positive. And then I do exactly the same with the little bit one behind, and I get negative. And then I say the change of sign indicates the presence of a root. Therefore, x is equal to 1,97 correct to 2 decimal places. So in the last question, I'm just also going to include that. Okay. Okay, let's go to the question. Now, number 1 is more or less the same. I don't think it's very difficult. I decided to just do a little bit other one with other mathematics bringing in, and that's why I'm going to do number 2. So you can stop the video. You can do number 2, and as soon as you are finished, you can continue the video. It's not really, it looks difficult, but it's not really so difficult. Number 2. The diagram shows the curve. That is very important. That is the curve. That's the curve. And it's between 0 and a half pi. A rectangle OABC. So just take notice, that's the rectangle. Okay. Where B is the point, just please take. So if B is that point, that means there will be theta and there will be cos theta. Are you with me? Okay. So the x value and the y value, and that's what they say. Where B is the point on the curve with x theta, and A and C are on the axis. So A, where's A and C? We have that as shown. The shaded region R, let's make that blue. The shaded region R is bounded by the curve and the line x equals there and between there. Remember, this is always y is equal. It's the x-axis, but the equation is y equals 0. Okay, now I'm going to start. Number A. Find the area R, so I'm with R, so I think we're going to do R in terms of theta. Okay, now let's start. What is the equation? The equation is y equals cos x. Now, if you think of area and you think of curve, you always must think of integration. If you think of gradient curve, you think of differentiation. But now integration. So I'm going to integrate that. And what is my points? It's that one, a half pi. And that, please be careful not to let it look like a 0. It's theta. Okay. And then it's cos x, and I will integrate to x. Okay. And I forgot to say that's the area of R. Okay. And now I'm just going to do that. Now, if I integrate cos, what is that going to be? Please, otherwise go to your summary at the back of chapter 12. But that's sin x. And then that's going to be a half pi, and that's theta. Okay, and then I substitute. So it's sin, okay, and now I'm just going to say it's a half pi minus sin theta. Okay, now just think of your graph again. This one you can work out, this one you cannot work out. If you think of, and you have to know your basic graphs. I repeat it a lot of times. I said you must know your basic graphs. Okay, so if you're going to think of sin, the sin is like this. Okay, and there's pi, and there is pi over 2 or a half pi. And the max, it's there 1, and the minimum is -1. So there, it's just in this place, I can put a 1. And there is my sin theta. Okay. Okay, and that is, so I just want to go and say, therefore, area of R, you don't have, it's just because I was not writing it good there, and 1 minus sin theta. Okay, now we go on to number B. The area of the rectangle is equal to the area of R. Okay, but first let's get the area of the rectangle. Area of rectangle, and if you want to name it, it's OABC. OABC. Now the area of a rectangle is just normal length times breadth. Now this, okay, let's call this the breadth, and we can call this the length, okay, because it looks longer. But that's from 0, okay, so this is cos theta times just theta. But please, you cannot come into, you write it as theta cos theta. Remember, it's not cos theta times cos theta. Then it will be cos square theta. But then there must stand another cos. There's not another cos. So put that in front. Okay. Now, the statement said that the area of the rectangle is equal to the area of R. So I'm going to say, I'm basically saying this two, they will be equal. So this will be equal to this. So I'm going to say 1 minus, okay, so area, let's just write it nice first. Area of rectangle equals area of R. Okay. Now, what is the area of the rectangle? The area of the rectangle is going to be this one. So, theta plus, no, not plus, it's multiply, sorry. Come on. Theta cos theta is equal to 1 minus sin theta. And now I can just already start looking there. And then basically all that I can do, I divide cos theta, I divide cos theta. So theta is equal to 1 minus sin theta divide cos theta. Okay. And that's what I should show that. So therefore, okay. Now they go on, they say use the iterative formula with initial value, they give it to you, 0.5, to determine the value of theta, correct to 2 decimal places. Give the results of each iteration to 4 decimal. Okay, so I'm going to do again C here. I don't like that line always coming in. Okay. So they tell you first, they say the first theta is 0.5. Okay, I'm not going to make the table anymore. I think you're now good. You can do it the short way. Then I know the formula is n plus 1. And don't forget, this is also the formula for fx. Are you with me? If I substitute to see the sign change, I work with the small letter f, but now I'm with the big letter. Okay. So I'm going to say fx, and then I'm going to just press it in here. So it's going to be that 1 minus sin theta over n. Now, I think that's also a printing mistake. That n must not be in the air. Sorry, I will correct it in. It must just also be on the bottom. Okay, so cos theta n. Okay, so I'm going to put in my calculator, I'm going to say, okay, 0.5, and then I'm going to press equal. Okay, and now I'm going to say that I will get Q2. And now I will put a bracket, because if you don't put a bracket, then only this 2 will divide. Are you with me? And it's actually this whole 1 minus sin theta that must divide. So put a bracket. So bracket 1 minus sin answer, close the bracket, divide cos answer equals. Okay, and now I'm going to start writing it down. So Q2, that's 0, let's just go to the yellow again, 0.5932. Okay. And if I approximate it, it's 0.59. Now this one is actually interesting. Okay, let's just go. Press equal, I'll show you now. So this is 0.5319. And if I approximate it to 2, then it's 0.53. And then I press equal, and it's 0.5719. Oh, that 7 didn't come out. Nice. Okay, and if I approximate it, it's 0.57. And if I do this one, equals 0.5456, and if I approximate it, 0.55. Q6, okay, equals, so 0.5628, and if I approximate it, 0.56. Okay, and then Q7, usually it's not so long. This one is interesting. 0, maybe the practical aspect. 515. And if I and now can you see it was, and now it must be 2 next to each other. So let's just go on. So it's 0.55, but that's not the answer. It must give you 2 consecutive answers. Okay. So let's go on. Now we are already at Q8. Oh, get my pen correct. Q8. So that's 0.5589. And that's 0.56. And still it's not consecutive. Okay, so let's just see which one of that 2 is going to win the battle. Okay, so equals, so it's 0.5541. And if it's 0.55. And I continue until I get consecutive. Okay, and then I go for Q10. Okay, so equals, so 0.5572. 0.5572. If I approximate, it's 0.56. I think we're almost done. Okay, and then let's see if it's now going to be consecutive. Equals. So it's 0.5552. And let's see what's this. 0. Oh, and there I got it. Do you see? The first 2, that's the same. Because the problem was, it was then the other one. It was done. And then for the first time, I got that the next 2 was the same. And the nice thing, if you wanted to go to 12, I just want to show you. That would have been 0.5565. And look what's happening now. It will also be 0.55. 0.56. Can you see now it's stabilized? It's stabilized. And you can end off by saying then correct to 2 decimal places. Therefore, correct to 2 decimal places. Theta is equal to 0.56. Okay, in this video, I want to include how we can also prove that that is going to be the root. So basically, what I'm going to do, it's almost like, as I said, the upper and lower bounds of 0.01. So if you subtract, so it's going to be 0.005 that you add. So it's going to be the one before is going to be 0.555, and the one behind is 0.56. Oh, let me just get that pen correct. Okay, come on, 6.5. Okay, so it's almost like, as I said, 0.01, and if you divide it to, it's 0.005, and then you, for the little bit before, you subtract, and for the little bit behind, you add. Okay, but let's do that. Then also remember, I cannot work. Whoa, it's so long, it's so many. Maybe I have to do it here. I think I'm going to, no, it's fine. I will just go back. Remember, I cannot work with this formula. I must actually work with this one. This is fx. Can I just show you? So I can, if I say there's theta and I bring that over, it's like I bring everything over to one side. Sin theta over cos theta. Okay. Or I can, and maybe I'm going to rather do the other option. Let's do the other option, is where I leave this on this side. So 1 minus sin theta over cos theta, and I bring this extra theta just over. Okay, let's work with that one. I think still it's better that I work here. Okay, it actually doesn't matter. Okay, let's go and work at the end. Just hope my pen will still work there. Okay, prove that 0.56 is the root. Okay. The root. So I'm going to go and first get my fx. And what did I say was the fx? Can you remember now? I said we're going to say 1 minus sin theta over cos theta, and we subtract that theta. It's not capital letter. Okay, and now I'm going to substitute. So let's just go and substitute the 0.555. And that will just be 1 minus sin 0.555 over cos 0.555 minus 0.555. All right, let's just press it on the calculator. Remember again your brackets. So say 1 minus sin 0.555, close the bracket, divide cos 0.555, press equal, and then minus 0.555. Oh, sorry, my calculator is an error. Let's try again. 1 minus sin 0.555, close the bracket, divide cos 0.555 equals, and then subtract 0.555 equals. Okay, and I'm going to get now, it's just a positive, it's just 1,60 times 10 to the power negative 3, but it's still positive. Okay, then I'm going to check my other one, so if, and now I'm going to check 0.565. Okay, so it's going to be 1 minus sin, again the bracket, 0.565, divide cos 0.565 minus 0.555 0.565 equals. Okay, let's start. Bracket 1 minus sin 0.565, close the bracket, divide cos 0.565 equals, subtract 0.565 equals, oh, there comes the negative, 0.0149 times, no, that is just the answer. You could have made it, but I'm just going to leave it like that. And then you can just say, there is a, therefore, let's just move it up. There is a sign change. There is a sign change in the interval uh, 0.555 and 0.565. So corrected to the root, corrected to decimal places. Let's just go in. So the root correct to 2 decimal places is 0. And that's that original 5, 6. And I just showed you how also to do that extra part.